back to my tutorial channel. Daniel's here, and today I'm going to continue on topics 8, hypothesis testing, and I'm going to go to part 3, t-test. So for t-test, we first need to know when to use t-test. And for t-test, to perform a t-test, we have two methods: critical value method and the p-value method, just like z-test. So first, when to use a t-test. Let's look at this situation. Do low-fat diets work? The following study was reported in the Journal of American Medical Association 297, 969, 977. A total of 76 subjects was placed on a low-fat diet. After 12 months, their sample mean weight loss was 2.2 kilograms with a sample standard deviation of 6.1 kilograms. How strong is the evidence that people who adhere to this diet will lose weight on the average? So here we have two possibilities. That is either the people who adhere to this diet will lose weight or will not lose weight. If people here will not lose weight, the weight loss mean should be 0. If they do lose weight, the mean weight loss is greater than 0, is positive. And on this example, we don't know anything about the population. We just have a sample of 76 subjects, and we have the sample standard deviation. This is 6.1. This is the sample standard deviation, which is the standard deviation from the sample. So in this situation, we are testing the population mean, but we do not know the population standard deviation. So t-test is used to test the population mean when the population standard deviation is unknown. Last time when we perform a z-test, we also test for a population mean. However, for z-test, the population standard deviation is known. So if the standard deviation is unknown, we just switch from z-test to t-test. Because when standard deviation is unknown, instead of using normal standard normal distribution, we use the student t distribution instead. And just like z-test, there are two testing methods to perform a t-test. The first method is the critical value method, and the second one is the p-value method. So let's look at the first method, the critical value method. For when we perform a hypothesis testing, we basically use the test statistics from a sample to make inferences toward the population parameter. And here we are interested in the population mean. So the population mean is the parameter, and the best estimate for the population mean is the sample mean. However, here we don't know population standard deviation, so we need to use student t-test. And for student t-test, the t-score of a sample mean is t is equal to x bar minus mu over s over square root of 8. Just different from z-test. From z-test, we use sigma. When we don't know sigma, we replace sigma by s, because s is an estimate of sigma. And here we assume that the null hypothesis is true. When you do a hypothesis testing, we always assume that the null hypothesis is true. So since we assume that the null hypothesis is true, that means mu is equal to mu naught. So we have mu here in the formula instead of mu naught. And the idea of the critical method is just find a critical value that separates the regions of the unusual values and the region of usual values. So let's infer denote the chosen significance level. the critical values and the critical regions depend on whether we have a left test, right test, or two-tailed test. So suppose we have a left-tailed test. The critical value should be minus T alpha, and degrees of freedom is in -1. Suppose that the symbol psi is in. And the critical region is the area to the left of the critical value under the student T distribution curve. For the right-tailed test, the critical value is T alpha with degrees of freedom in -1, and the critical region is the area to the right of the critical value under the student T distribution curve. And if we have a two-tailed test, we have two critical values, the minus T alpha half and T alpha half, and we have two critical regions. Those are the two tails under the student T curve. So basically we want the critical region, the area of the critical region to be alpha, and the area of the exception region to be 1 minus alpha, 1 subtract alpha. So for left-tailed, the critical value is minus T alpha n minus 1, which has area alpha to its left, and we reject x naught if the test falls into the critical regions. So for the left tail, if the test falls into the critical regions, we have t is less than or equal to minus T alpha n minus 1. For the right tail, the critical value is T alpha n minus 1, and if the test falls into the critical region, which is the shaded area here, we have t is greater or equal to T alpha n minus 1. For two-tailed, the critical values are T alpha half, which has area alpha to its right, and minus T alpha half, which has area alpha half to its left. And we reject the null hypothesis if the test falls into the critical regions. Here we have two critical regions, so either T, the test is less than the negative critical value, or T is greater than the positive critical value. So that is the idea of the critical value method. And the procedure to perform a t-test by the critical value method is, first we have to state the null and the alternate hypotheses. Step 2, we choose a significance level, alpha, and find the critical values or values. We have to compute the test statistics. Here the test statistics is t equal to x bar minus mu over s over square n, assuming that the null hypothesis is true. Degrees of freedom is n minus 1. Step 4, we have to determine whether to reject the null hypothesis as follows. For left tail, if the test statistic is less than the critical value, we reject the null hypothesis. For right tail, if the test statistic is greater than the critical value, we reject the null hypothesis. For two-tail, we reject x naught if t is greater or equal to T alpha half or t less than minus T alpha half. So for left tail, we have negative critical value. For right tail, we have positive critical value. And for two-tail, we have one negative, one positive critical values. Simply, if the test falls into the rejection region, that means the critical region, we reject the null hypothesis. And step 5, we state a conclusion. So that was the critical value methods. Now we look at the p-value method. The p-value method to measure just how strong the evidence against the null hypothesis is. We compute a quantity called the p-value. The p-value is the probability that a number drawn from the distribution of the sample mean will be as extreme as or more extreme than our observed value of sample mean. The more extreme the value, the stronger is the evidence against the null hypothesis. The p-value is the probability, assuming that the null hypothesis is true, of observing a value of the test that is as extreme as or more extreme than the value actually observed. The smaller the p-value, the stronger the evidence against the null hypothesis. So here for p-value methods, we have to compute a quantity called the p-value. If we have a left tail test, we mark the test status on the picture. This is the student T curve. We mark the test status. So the p-value is the area to the left of the test status under the student T distribution curve. For the right tail, the p-value is the area to the right of the critical value under the student T distribution curve. And for two tails, once you have the test status, if the test status is positive, you have to find is negative. If the test status is negative, you have to find is positive and mark them both on the picture. So the p-value is the area of the two tails. So the p-value methods. Step 1, we have to state the null and the alternate hypothesis. Step 2, if making a decision, choose a significance level alpha. Step 3, compute the test status and the degrees of freedom. Step 4, compute the p-value of the test status. Left tail, the p-value is the area to the left of the test status. Right tail, the p-value is the area to the right of the test status. Two tails, the p-value is the areas to the left of the negative test status and the area to the right of the positive test status, or 2 times the area to the right of the positive test status, or 2 times the area to the left of the negative test status. Step 5, if the p-value is less than alpha, we reject the null hypothesis. So that was how we perform a test. Now let's practice on an example. Example 1, do low-fat diets work? The following study was reported in the Journal of American Medical Association. A total of 76 subjects was placed on a low-fat diet. After 12 months, their sample mean weight loss was 2.2 kilograms with a sample standard deviation of 6.1 kilograms. How strong is the evidence that people who adhere to this diet will lose weight on the average? So first, we have to summarize the information. Here we have 76, 6.1, 2.2. These are the 3 important information. So here, if first we have to define the specified value of the null hypothesis. Here, since there are 2 possibilities. Either the people who adhere to this diet will lose weight. That means the mean weight loss is positive, or the people who adhere to this diet will not lose weight, so the sample mean weight loss is 0. So the specified values mu naught is 0, and if we assume that the null hypothesis is true, mu is equal to 0. Here we have a sample of 76 subjects, and 6.6 is the standard deviation of the sample. 2.2 is the sample mean, the mean of the sample. N is 76, the sample size. So here we have the null hypothesis is mu is equal to 0, and the alternative is mu is greater than 0. This is right tail. The null hypothesis states that the people who adhere to this diet will not lose weight. That means the program is not effective. The alternate hypothesis say that the people who adhere to this diet will lose weight. That means the method was successful. And if you read a question and the confidence level is not given, you have to take alpha is equal to 0.05. Like usually if alpha is not given, we take alpha as 0.05. So now let's see how we perform a test. First, we have to find the test status. T here is equal to x bar minus mu naught over s over square of n, which is 3.144. By the critical value method, this is the right tail, so we have to find T alpha, with degrees of freedom 75. Because for right tail, the critical value should be a positive value and the area to its right is alpha. So the critical value T.05, 75. Here the sample size is 76, so the degrees of freedom is 75. And it is equal to 1.67. So on the picture, this is the student T curve. T alpha here is 1.67. The critical regions is the area to its right. And we see that the critical region is 1.67 to infinity. And the test is 3.144. 3.144 does fall into the critical regions. So we reject the null hypothesis. By the p-value method, here we have a right tail test. So the p-value is the area to the right of the test statistic under the student T curve. And it is equal to 1 subtract the area to its left. And the p-value in this case 0.0012, which is sufficiently small, very small. This is strongly smaller than alpha. So we strongly reject the null hypothesis. So we reject the null hypothesis. We have enough evidence to reject the null hypothesis. That means we accept the alternative hypothesis. So the program, people who adhere to the diet, to this diet, will lose weight in average. So conclusion, there is sufficient evidence to conclude that people who adhere to this diet will lose weight on the average. So we see that t-test, actually t-test and z-test, quite similar. The only thing different is when we perform a t-test, you replace anywhere you see sigma and z-test by s. And for t-test, you have to find the degrees of freedom. On the picture, instead of marking the z-score, the z-value, we mark the t-score, the t-values. And the procedures should be the same. Alright, so that's it for today. Thank you so much for watching my video. I hope you guys find my video helpful. And see you next time. Bye.